Today I would like to discuss about dyes. What are dyes? Dyes are colored organic compounds having the property of firmly imparting color to other substances such as textile fibers, wool, silk, leather, paper, inks, toys, hair, foodstuff, etc. Examples are malachite green, orange 1, orange 2, alizarin, etc. Requirements of a dye. It must have a suitable color. It must be capable of fixing itself to the material being dyed. When fixed to the material, it must retain its color even on prolonged exposure to sunlight, heat and other atmospheric conditions, and when treated with water and soap during washing. This property is called fastness of the dye. It must be fast to other ordinary chemicals that are used during dry cleaning of dyed clothes. Sufficient solubility of a dye in water or in suitable aqueous solutions is also a preferable characteristic of a good dye because it makes the process of dyeing easier. There are many theories associated with dyes. The first one is Witt's theory. Salient features. The structures of dyes are essentially made up of two parts, namely chromophores and oxochromes. A chromophore is a group that produces color. The presence of at least one such group is essential to produce a color in an organic compound. A compound containing at least one chromophore is called a chromogen. Most of the chromophoric groups have unsaturation in them. Examples for a few chromophores are given below: nitro, nitroso, azo, azoxy, carbonyl, thiocarbonyl, p-quinonoid, ethylenic groups. The greater the number of chromophores in a chromogen, the greater is the intensity of its color. The color intensity also increases with increase in the extent of conjugation. Example, ethene is colorless, but the compound CH3CH double bond CH6CH3 is yellow in color. Similarly, nitrobenzene is pale yellow and azobenzene is orange red. Certain chromophores like the carbonyl produce color only when two or more of them are present in a molecule and they are conjugated. Thus, while acetone is colorless, biacetyl is yellow. An oxochrome is a group which, while not producing any color by itself, is able to intensity the color of a compound when present together with a chromophore in it. The presence of oxochromes is essential for a chromogen to function as a dye. Example, the chromogen azobenzene is orange-red in color, but it is not a dye. On the other hand, the compound p-hydroxyazobenzene is a bright red dye. In p-hydroxyazobenzene, the chromophore is a diazo group, the chromogen is a azobenzene portion, and oxochrome is a hydroxyl group. According to Witt's theory, it is the combined presence of chromophoric groups and oxochromic groups that enables a compound to act as a dye. Next theory is valence bond theory. Silent features. Chromophores, that is, the groups that produce color in a compound, are the groups in which pi electrons get excited from lower levels to higher levels by absorption of radiation quanta in the visible region. This produces color in those chromogens. Oxochromes augment resonance in the chromogens by allowing interaction of their lone pairs with the pi electrons of the chromogens. Example, aromatic rings. This enhancement of resonance results in a bathochromic shift or red shift, that is, a shift of absorption from lower to higher wavelength. That is how there occurs a deepening of color when oxochromes are present attached to chromogens. For example, let us compare the colors of nitrobenzene and p-nitroaniline. The resonance structures of nitrobenzene given below. Though the chromophore NO2 group is present, nitrobenzene has only a pale yellow color. Now consider the resonance structures of p-nitroaniline. The attachment of the oxochrome NH2 group showing plus some effect makes more charged resonance structures possible for p-nitroaniline than for nitrobenzene. The NH2 group present at the para position of nitrobenzene thus shifts the absorption to longer wavelengths, that is bathochromic shift, with consequent color deepening. As a result, the color of p-nitroaniline is orange-red. By attaching suitable oxochromes to chromogens having more conjugated systems of double bonds and thereby providing longer paths for resonance, the color can be suitably deepened to that required for a dye. Thank you.